Hello, and this is Ivan at Talk to My Car. Welcome you back once again to our videos. Today we are going to have a chat about intake air temperature and engine coolant temperature sensor operation. These two sensors and any other temperature related sensor on the car operate in a similar fashion. They're in a group of electrical conductors called thermistors. In other words, they are resistors that change resistance with temperature. The intake air temperature, in short IAT, and the engine coolant temperature sensor have what is called the negative temperature coefficient. What that means is as their temperature rises, their resistance falls. So they have more current going through for any voltage. They have more current going through them when they are warmer than when they are cold. Now, thermistors or temperature sensors on the vehicle, including the IAT and the ECT, are usually two-wire sensors. As you can see in this image here, it's got one wire, which is a ground or earth or negative, if you want to call it that. Which is this wire that comes from the ECM, the engine control module, will usually be tied into the pin 5 of the OBD2 for cars which have OBD2 ports. That's cars after around 2000. Some are even earlier models, but most cars after 2000, 2001 have an OBD2 16-pin port. Now, pin 5 on that port will usually be the sensor ground, and this connection here on the temperature sensor will be connected to that, and on the other wire, which is also coming from the ECM, will be a 5-volt reference voltage, and this is actually the signal line. This is what tells the computer what the temperature of whatever this sensor is inserted into, whether it is oil temperature, whether it is coolant temperature, whether it is air that is going into the manifold and the engine. The signal will come from this wire on this end. It's basically what you have is this wire going in there like that. Then there's a resistor in there which changes the resistance with temperature, and then the wire comes out. It's that simple. When you are, if you bring the vehicle to Talk to My Car for vehicle diagnostics, and we are able to get you a code that's related to the temperature sensor, you will find that you don't always have to change the sensor immediately. Sometimes it's just the wires from the ECM, from the computer, that are broken. So you guys that are fixing these vehicles, whether you are professionals or doing it in a DIY format, doing it yourself, please don't always assume when you get a code related to a sensor that the sensor is faulty. You have to do some wiring tests to prove that it is the sensor that's faulty, or it's the wiring that's the problem, or it is the computer itself that's a problem. Sometimes it's the computer itself. which is the problem, but you have to prove it. Don't make a customer keep buying parts, or if you're fixing the vehicle yourself, don't keep spending money on a sensor. If, for example, the wire is broken, you get the same code. You get a similar code to when the sensor is broken, when it's ruined. So if you keep changing sensors when it's a wire that's broken, well, you're spending money for nothing. So be careful. Some of these tests are really not that complicated. I'll show you. This wire here, this connection here, if it's plugged into its socket, you always get 0 volts on it, with somewhere near near 0 volts, very near 0 volts, because this is a ground connection. On this side, you should see for most vehicles, the sensor voltage, sensor feed is usually, sensor reference voltage is usually 5 volts. So, and this the voltage on this wire for this thermistor will change from 5 depending on the resistance in here, which will change with the temperature. So if the computer puts 5 volts here, the computer will keep pushing 5 volts into here. Now what happens is, because there is a resistor here that is now connected to the ground, current will flow, and that means the 5 volts that are sent by the computer here will drop. Now depending on the temperature in here, which determines the resistance in here, the voltage on this line, although the computer is pushing out 5 volts, the voltage on this line will fall with increased temperature, because with increased temperature, the resistance in here decreases, so more current flows, and therefore the voltage on this wire falls. So computer puts 5 volts here. Briefly, let me explain that again. Computer puts 5 volts here. They go into the resistor. Circuit is completed because the sensor is good, and this will remain at 0, but this will change. This voltage here will change, and then the computer will check. It knows it is putting out 5 volts, so it watches to see what voltage remains here. If any part of this sensor wiring is broken, then if it is broken on this side, you have 5 volts both here and here. If it is broken somewhere inside the sensor or on this side of the circuit, you have 5 volts on this side and 0 volts on this side. If it is broken, if the wire, this wire between this connection here, the 5 volt reference connection, and the computer is broken, then you have 0 volts here as well. It's basically simple electrical knowledge, so you can follow the breakage of the circuit. So before you change the sensor, please check the wiring. Sometimes the wiring is a problem, it's broken, and then the computer sees. I've mentioned that the computer puts 5 volts on this wire. Now it is waiting to see a reduction in that voltage, in that 5 volts. If it is very high, as in 5 volts, it's not being, it has put there 5 volts and it is still seeing 5 volts there, regardless of the temperature, because even on the coldest temperature, that voltage here should fall a bit, up to maybe 4.2 or 4 volts or something. If it keeps seeing 5 volts here, it knows that either this sensor is broken or this ground connection is broken. If it sees very close, very close to 0, then it knows that this wire here is grounded. It has got a short to ground, a short to the frame, a short to the negative. That's why it is not seeing 5 volts here. So the codes it throws out will depend on that. Usually the code for modern vehicles, the code will even be specific. It will tell you whether it is seeing a very high voltage, and it will say something like I80 sensor voltage high, which it doesn't mean that the temperature of whatever the sensor is measuring is high. It is just telling you it has sensed a breakage in the wiring. And same thing applies to the I80 sensor voltage low. With that, it means it is trying to tell you that you've got a short on the 5-volt reference wire. Either that or the computer itself is damaged. So moving on to how you will practically test this sensor. I've included that image you are seeing on the screen. Basically, you can do a quick test. On this wire, which I mentioned should be connected to the negative or to the ground, to prove that this wire is okay, because now what you're trying to do is to prove that this sensor is bad. It's not the wiring which is a problem. Now, if this wire is okay, this one, if it's connected to the ground, put your multimeter in that format, connect the black lead to this negative terminal, and then connect the positive lead to the battery positive terminal. You should see 12 volts here. This image is saying 6 volts, but here I'm explaining to you, you should be seeing 12 volts. If you don't, then it means this wire here, this wire here going to the negative or the ground is broken. Then after that, change the voltmeter to this terminal, the positive one. You began with this, change it this one. If this one is proven okay, you see 12 volts on it. When you connect this here and this one to the positive terminal, rather this one to the positive terminal and this to the negative terminal. If you now connect it to this wire like is shown in the image, connect this black wire to the ground or the negative terminal of the battery, of the car battery now, and then connect this wire to the positive terminal of the sensor. By the way, do these tests with the sensor disconnected. Pull the sensor out of the connector and do these tests to prove that the wiring is okay. If when you do this, negative here connected there, then positive connected to this one, and you see 5 volts, it means both your wiring and your computer are very okay. Right? You are now almost sure that it is the sensor that's playing. Now, next, plug. Okay, before you go to the test which prove that the sensor is actually dead, you now have about 60% proof that it is most likely the sensor. When you make this connection, make sure when you are testing this side of the wire before you plug it in, make sure you get very close to 5 volts. 4.6 to 5 volts. 4.6 is acceptable, but in my experience, I don't like it. Most computers, even with a low battery, will give you somewhere very near 5 volts. Minimum maybe 4.9. If you see 4.6, your battery could be bad, but most likely you have some resistance in this wire, some unwanted resistance in this wire, maybe corrosion or something. Please take note of that. Now reconnect the temperature sensor and then go for this wire, because it is a signal wire which the computer monitors. Now you should have, if the engine is cold, the resistance in here will be very high. The resistance in here will be very high, so you see a rather high temperature, rather high voltage in here because not a lot of current will be flowing. As this heats up, the resistance in here goes down and more current flows, so the temperature on here will fall to about maybe a minimum of 1. By the time you're at around 100 degrees centigrade, it will be about 1.2, somewhere there. If it comes very close to 0, no, again, that's not good. The sensor is not good. That's about it. And I would always want to use wiring diagrams to explain what I've just been saying. In this diagram, this is taken from a 7A FE engine from a Toyota Corolla. Maybe they have put the Toyota have put some of those in Carinas and some other Premios, I think. But you find the 7A engine mostly in the Toyota Corolla Chikumi Kumi, the AE110 and its related variants. Now we have the coolant temperature sensor here, the ECT. You see it has 2 wires, and you see this, they have even shown you the color. This is why I like using wiring diagrams when I'm troubleshooting, and please endeavor to do the same. Always have the correct wiring diagrams, and you find life very easy. Then this wire, which is N, meaning brown, usually the N for Toyota means the brown color because it's the one they normally use for neutral. You see how it is connected to other sensors, like this is the throttle position sensor, and then you have it connected to the manifold air pressure sensor as well, and then you have it connected to the air temperature as well, air temperature sensor as well. This sensor here and this coolant temperature sensor are similar in how they operate. You can see they have 2 wires, and they even share a negative wire, this one, all the way from the computer. This is the computer here. This is the terminal. They even show you the terminal. When you take the computer out, you look at it and relate the positions of these pins to the wires here. And they've even shown you the color of the wires. You can follow the circuit. For example, if you are getting a code related to this intake air temperature sensor, you can follow it up to here, and then this yellow yellow wire with a black stripe, in this case, is the one that belongs to the intake air temperature sensor signal wire, which will go back like that. You have now noticed that it is a single wire, not connected to anything else, because it is a signal wire specifically for this sensor. The neutral can be shared on all these sensors. The signal wires are always separate. You can see that here. You can see that here. They only share the negative. Look at that diagram more carefully if you wish. The NOx sensor looks like it has 1 wire. This is the signal wire. It has 2 wires. It operates using 2 wires, but it gets its negative or grounding because it's fixed on the block of the engine. It gets its negative from the engine, from being the screws, the grooves on the engine. That's why it doesn't have a wire. The electrical path is like that. This is the engine block here. It is fitted into the engine block. So its current will flow like that into the engine block. These are plastic wires, rather plastic sensors. They have plastic molding, so they need a wire back to the negative terminal. So it's very useful to follow wiring diagrams to troubleshoot these problems. If you learn, if you teach yourself how to use wiring diagrams, you really find life, when you're doing vehicle diagnostics, you find life very, very easy. Thank you for showing interest in this video. At Talk to My Car, we are here to save you time, money, and headaches. T2MC works in partnership with SSK Motor Garage in Chaliwajala, and you can find us when you call. If you want to call, you can find us on the numbers shown on the screen. Otherwise, you can find us on our Facebook group page, whose link I've been showing you earlier in the videos. If you need to see that link, you can rewind the video and come and share your queries, any queries, or if you have any questions, if you need any help securing wiring diagrams. We are willing to share a lot of things. Please either call us or come and join our Facebook group forum for discussion. Thank you for your attention and time.